Hey everybody, this is Chip Freeney. I'm a lead UX designer at Gulfstream Aerospace. I'm going to talk to you today about a recent project we've done in the AR space and how we designed an app for the Hololens in aerospace manufacturing. Some of the learning objectives today, I want to cover a broad audience, but we're going to talk about sort of catch everyone up, the capabilities of the device we're using, how we chose our use case, and how you can choose a good use case for your team if you dive into this. I want to focus on some of the key design challenges that we came through. I'm a UX designer, so that's going to be my area that I care about the most, but there's obviously a lot that goes into these projects. And then we're going to wrap it up with the dev design process. So kind of how we work together as a team in a new medium. We're used to building iOS and web apps, so it was a little bit different to build things in 3D. And I'll talk through some of how we did some of that stuff. So first and foremost, about the HoloLens 2, this is the device we chose to bring into Gulfstream. We've got a lot of AR stuff going on. We have a team that really solely focuses on trying out new technology, and this has been really promising. And I'll talk you through kind of why it works for us. But the HoloLens 2, built by Microsoft, it's augmented reality. So if you can see this woman is wearing the headset, it's a clear lens, so you can still see the world around you. It's adding things to what you see. It's not obscuring anything like a virtual reality set would be. So that's really good for safety reasons. We've got, climbing up and down ladders, crawling all over planes. You need to be able to see where you're going. It's fully wireless. You can see the front is really the meat of what's going on, and then the back is the battery, and it balances pretty well there. Speaking of battery, it's about 2 to 4 hours of battery life. We're getting about 2.5. We have a pretty heavy application that's doing a lot of 3D renders, so I think it's more on the lower end of that. But Microsoft says you can get up to 4 depending on what you're doing. As far as precision, Microsoft claims between 1 centimeter and 3 centimeters of precision. We're on a little bit of the higher end of that because we're trying to track an entire aircraft. I think they told us if you're at a smaller use case like a desk or a workstation, they can get a lot more precise because you're not having to track as many things. And we'll go into that, like how that led to our use case. Some of the inputs, so there's no some of the Vive and some of the VR things have like a controller or something. This is just your hands. So it's got cameras on the front that can see everything around you, LiDAR that's sensing the environment, and then it's also sensing your hand gesture. So that's really the meat and potatoes of the input is your hands. Also, your voice and your gaze. So it has eye tracking, so it can actually tell what you're looking at, like where your eyes are pointed, and you can use that for some of your inputs. The outputs are holograms, which are things, the 3-dimensional things that are in the world, and they really stay. So if you put something in the world and you move around, it's going to remain where you left it, kind of like similar augmented reality technologies. Versus heads-up display, you can also leave things that are kind of glued to your face, so like status trackers or counters or things that really move with you. And then sound. We weren't able to utilize as much sound because we're in a very loud manufacturing environment, and I'll go into that later, but it is one of the outputs. Another big factor of choosing this device was that it works with prescription and safety glasses. So if you look at this photo of the woman wearing the headset, there's actually some gap between her eyes and the HoloLens lens, which means that she has space to put on prescription glasses, safety glasses, any other things she might need. At Gulfstream, we have a requirement for side protection on safety glasses. So if you were to be working and a rivet were to fly in from the side, we have to be protected. So that's really good. You can actually wear your safety glasses underneath this device and still be safe and protected. So all those things led to kind of why we chose this device to bring in, but also this led to our choosing a use case, and I'll go into that next. So electrical decals. So an aircraft has literally thousands of wires that run all over the place from point A to point B. When you've got thousands of point A's and point B's, it's wise to label them. So that's what this is. We label our destinations, we call them reference designators, but they have a sticker. So you can see on the left, there's 3 terminal posts where wires end up, and those 3 terminal posts have stickers on them. Those are called decals. So the current process today is that we have thousands of those things, and they're sliced up into work orders. And what technicians do is they print screen from AutoCAD, CATIA. They then take a paper copy and they label it themselves with where the stickers go based on them kind of panning and zooming around the 3D model. And they build these binders. So they carry the binders onto the plane with them. That shows them where the decals need to go. So anyone listening who's in manufacturing can imagine the things that are wrong with that. You've got human error making it, you've got human error installing those things, and you've got the time consuming having to make those guides. And then you've also got, if you were to make an update, now you've got to go track down paper copies and get those out of circulation. Um, Obviously, from a quality perspective, everything is checked by inspectors, so there's not a risk of things going out the door incorrectly. It's just a matter of having to rework things. So we really wanted to tackle this use case and help these guys out, and we thought that the Hololens would be a good fit for that. So it kind of leads us into our use case and how you could choose your use case. So why decals? They have a high tolerance, so unlike a lot of things on the aircraft that are really like millimeter specific, we're able to, these are they have to be within 1 inch of the place they're supposed to be, because they're really just a sticker that shows you those poles, what they're labeled as. So I mentioned before, the HoloLens has a 1 to 3 centimeter tolerance. This has a 1 inch tolerance, which is about 3 centimeters. So it worked out perfectly for that. It's also low risk. There's no welding, there's no hole drilling. If you were to make a mistake, if the technology were to mess up for some reason, all you got to do is a sticker. So that really helped sell it to the business and to the guys over on the manufacturing floor who were doing the work of, if you were to mess up, it's not going to cost you much time. The data is really hard to remember. There's thousands of these stickers. The where they go is kind of the easy part. It's the which one goes where was the big question. So that really helped out too. We can use this for labeling and really have a good use case to dive into that isn't like super specific, like where should I drill this hole or how do I do this specific process. Another good thing as far as bringing in technology to the company is this task is not a specialized task. It doesn't require a specialized skill or certification. Anybody can put on a sticker. So that made it really easy for us to test and really easy to demo. So any technician could put the headset on, try it out. We could do usability testing, understand what worked for them. But also when we were trying to demo to executives and leadership, it wasn't something they weren't qualified to do. So our CIO put on the headset and was able to put stickers on. And that was really great for us to be able to show the power of this tool and be able to, that's why we have a couple more projects coming in, because this was easy to share and really easy to get people on board with. So getting into the app overview, this is what we ended up with. I'm going to dive into each of these pieces a little deeper later in the presentation, but the overview of this app is if you're a technician, you put on the headset outside of the plane, you're going to get a quick safety notice. Please be, mind your surroundings, be aware of your surroundings. That was something that our safety team and legal teams had some input on. We were happy to comply with that. Then you move into selecting your work order, scanning the aircraft to align the model, and I'll talk a bunch about that. Once you've got everything lined up, you can see the data, you can see the stickers floating in midair. You can go place them, mark them off, and then at any point you can open your hand and use Microsoft, it's called the hand menu, but you can realign the aircraft, change work orders, do a couple of different things in that menu. That's the overview of the app. So what I want to talk for really the designers and some stuff that I wish I had known going into this, there's really 3 big challenges of a project like this. Aligning the model, like the 3D model in the real world, selecting your task, and then displaying the actual data. So that's where we spent the majority of our design time and our testing time. And I'm going to dive into each one and kind of hopefully share with y'all some of the ways we thought about this and some things that I wish I had known going into it. Maybe y'all can build on some of these ideas. So the first thing we got to do is in an augmented reality project where we've got to display data in its actual place on a plane, you've got to line up the model. So on the right, this is not a Gulfstream, this is a Cessna, but most companies that manufacture things these days have a 3D model of what they're going to build. So you need to align that model and the real world exactly in place so that when you display parts, they'll show up in the right spot when you're walking around. There's really 3 schools of thought on how to do this. The first is object recognition. So like I said before, the HoloLens has cameras on it on the front, so it can see what you see. So if you give it a model, it can compare the model with what it's seeing in the world and try to line them up. We played with some libraries for that. It worked well for specific items like a book cover or like a peanut butter jar or something, a toy car, but it didn't work so well for a large aircraft. I think the size, but also the repetitiveness of, like, if you look at this model, you can see there's a bunch of ribs on the wings. It's able to recognize I see a rib, but it's hard for it to know which rib it's looking at because they're all the same or at least very similar. The next thing is, okay, if we can't do that, we can triangulate. So that's how some of the virtual reality works, like the HTC Vive Pro has, if you've ever seen those like tripods with the RF sensors and infrared sensors, those are doing true triangulation and the device knows where it is in comparison to those sensors at all times. The HoloLens does not have that, but we kind of stole some ideas from the triangulation idea to get what we did. And the last way would be manual. So you could always plop a model down, pull out an Xbox controller, which syncs to the device, and like finagle it into place yourself. That's a great way to do a proof of concept before you have all this stuff working. And if I was there and we were doing user testing super early, we just lined it up with the Xbox controller. And then that allowed us to test a lot of the down the road features that required it to be lined up. But we knew that wasn't going to be a production ready solution. There's a lot of human error involved in there. And it was pretty tedious to do. So what we landed on was 3D printed QR codes. So we worked with some engineers and we built these jigs that would go to specific places on the aircraft. They clipped in with what's called a Clico attachment, if anyone's in manufacturing, but it's basically a super quick way to link something in place quickly. It's kind of like a chip clip, but there's something that technicians are used to doing, and they go in predefined holes. So what we can do with these QR codes is we have 3 of them, and they're placed throughout the aircraft, and they're always in the same location. So we had the engineers give us those XYZ locations, we place them into our software, and now when you walk around, the HoloLens can see those QR codes. It's much easier to recognize than, say, one of those green frames or some of these parts. So they're very easy to pick up on. And then once you've got those 3 locked in, the HoloLens is always mapping its environment. So it's got a mapped environment that it's comparing to the model it has, and it's actually pretty accurate. So this is some of the UI. We've got a kind of, if you've seen QR code scanners or like a check scanner, like in the Wells Fargo app or something, it's kind of what we used for this, but it tells you, hey, go find the QR codes. And as you scan more of them, it lines in better. So you see this is number 2, and it's still about an inch off. By the time you get to the 3rd one, it will have kind of locked in place and be a lot more accurate. Another thing that we did for this was the technicians need the confidence of knowing that the alignment has worked, but also that the alignment continues to stay in place while they're doing their job. So for lack of a better term, we're calling this reference structure. The idea being that we've got a bunch of stickers that we're rendering and where they should go, but they need some sort of reference to know if it's off. The stickers can't tell me that because I don't know where the stickers go in the first place. So we took real pieces of the model of the aircraft and put them in the rendering so they can line up and know where they are. So there's a scale of not show anything and just show the stickers, all the way to render every part in the plane. And obviously rendering every part from a performance standpoint isn't going to happen, but also it just gets confusing to the user. So we had to pick specific things that were unique in the plane that we wanted to render out. So in this case, we chose a couple of key, they look like ribs, but we actually call them frames. But that green piece that you see on the screen is a unique frame that's near the exit window. So we were able to use the exit windows, which are actually square, as opposed to the Gulfstream round windows. A couple of key frames that are different, and then a couple, one of the bulkheads in the front. And what that does for us is it's minimal, but it's just enough to show that the alignment is working. So in this, you can kind of see, if you look at the window, there's like the real window, and then there's the model of the window is about 1 inch higher and up to the left, just like that little blue square is. And if it's lined up correctly, you almost can't see this stuff. It almost disappears into your world. But when it is off, it's definitely off. So that's something that was really helpful for us to use, and it's really been a big help for the technicians. So hopefully y'all can get some value out of that stuff. Next thing was selecting the work order. So that was a big challenge for us. There's thousands of work orders in our system, and probably most companies' systems, and they're up to 16 characters long. So for our proof of concept, we were able to use the keyboard and type it in ourselves. Through some testing, we found that that was not really a useful or a usable way for technicians to input, because it was hard. And it's a floating keyboard, and this is not to knock Microsoft at all, but like it's just not as fast as some other methods might be. So we did some brainstorming, came up with a couple different ways that we could input the work order. Everything from voice recognition, which it wasn't successful in our environment just because it's so loud. Like we have rivet guns and fans and forklifts and everything. So voice recognition was not a reliable input. You can use a Bluetooth keyboard, but you run into some issues on keeping track of the keyboards and which headset is connected to which keyboard. We toured with the idea of some companion apps, like printing out a QR code or maybe some kind of web app. It just became kind of a scope creep as far as what we had to build and maintain. So we really landed back on, let's use some UI in the headset to do this. So that landed us on a tree structure. So we kind of ruled out a couple things, but the first thing you got to do is there's a bunch of different statuses of work orders. So there's everything from new, ready, active, pending, and complete. We talk to technicians and they're only pulling work orders that are ready or active. So off the bat, we can rule out 90% of work orders in the system. Next thing we did was we kind of landed on this tile-based model. So you can kind of reach out and tap a tile. So we were able to do a tree of department, station, and work order. So there's only 6 departments. So you pick your department. Each department has up to 6 stations. It's kind of the place where they work in the building. So there's another 6. And then by the time you've narrowed it down from station and department, there's only a handful of work orders, like up to 8 maybe, that are active for that one station at any given time. So this was way easier than trying to type out a 16-character work order number on a floating keyboard. So it's really just 3 taps and we can make the text really big. And this worked out really well. So hopefully that helps y'all too. Finally, showing the actual data was the funnest part of this project. Like I said, there's tons of stickers all over the plane, and they're not really, like, the work order doesn't necessarily pertain to a specific area. It's more based on the type of wires being run. So there can be anything from 10 stickers to 120 in a work order. There's no prescribed order. Like, the current day has no, like, first you do this one, then you do the next one. They really do it at their own pace and in their own order. That's driven sort of by, it doesn't have to be, but it's also because if someone is doing rivets in that area, you might go to a different area and finish that part of your work order and then come back. So we had to make our process line up with that as well. We've also got a loud environment, so we can't use a whole lot of voice input or output for, like, giving them guidance or for saying things like next, because they might not be able to hear it with the rivet guns and everything going on. Once we started testing the stuff, we got into some more challenges, and I'll go into those in the next slide. But we found people that were missing decals. We found people that were like, I wish I could check these off. And that's kind of the path we went down. So I'll talk through some of the iterations here. First iteration is on the left. This was our proof of concept to say, like, hey, can we get these things to show up in the right XYZ location? So we literally had like a rectangle that represented the sticker, and we slapped a part number or the label on top of it. There was obvious, stuff going on with that. It's crowded. It was hard to pick a contrast, like a good color, because there's, depending on where it is, it's either white background, green background, black background. It was hard to read sometimes. And it was also in the way. If you're trying to put a sticker on, those labels were often between you and where you're supposed to be. So our second iteration after that was, all right, let's take the labels and have them float. So we utilized Microsoft's Tooltip out of the MRTK, which I'll talk about that in a minute. But that gave us improved readability because you have a blue background slate with white text, so it was easier to read. It was no longer as crowded where your hands were trying to go. But we still had users missing decals. So we had a user test, and one of our technicians went through the whole work order. He was so happy that he got them all done. We got to the end, and he realized that he had only done about 50 of the 67 that were required because they were out of his field of view. So that led us to our next iteration, which was, I want to check things off. So I'll take it back up to, this is a little bit easier to see. But we got to the interactive tooltip. So there's a lot of things that happen when you do actually place the sticker and check the box off. Specifically, the label itself to the sticker, and then the sticker turning green was helpful for when you're in a crowded area with a lot of stickers, making sure that you've put the right sticker to the right label. Sometimes these little pigtails can get crisscrossed. We've done a bunch of stuff to prevent that. But in the case they don't, making sure that when you tap it, it turns the right sticker green helps you have a reference for which one I was actually supposed to be doing. So getting into our process, so we had a new team that was formed for this project. We have a mixed reality team at Gulfstream that really looks forward and experiments with a lot of new technology. And this was one of their first forays into what we call production apps, but building things that are going to be longstanding with support that are in the environment that people are using day in and day out. So we actually formed a team between myself, I'm on the UX team, and they were the mixed reality team. So we formed up, got a project manager involved, created a real project with a budget, and enrolled with it as an agile project. So we used 2-week sprints. We sketched flows in 2D and then pair coded with Unity. I tried to learn Unity. I still learned a little bit, but it was a lot for me to pick up working in a new medium, learning a new business process, getting to know a new team and helping them run agile, and also picking up Unity. So, don't be discouraged if you're a designer and you're like, I can't learn these new tools and design at the same time. It's totally fine. All the stuff I've showed you so far was all built in like Figma and Sketch, which I can just fly through. So we figured out that I can go way faster in those tools, and then we can screen share, and one of our developers can fly through Unity, and that was what worked best for us. I think for projects going forward, I'm going to try to learn more Unity, but I'm not going to get down on myself for not being as fast as these guys have been doing it for years. The other stuff, we user tested every week. So we went out to the hangar, let technicians put it on, tried it on ourselves every single week to get that feedback. And then we iterated based on that feedback. So all the stuff y'all saw with like iterating on the labels, we would not have known about that unless we had gone out to the field. Other than that, I put on the headset every day. It's really important to just be in it. So my wife is kind of mad. There's QR codes all over the house from all the Gulfstreams I've initiated inside the house. But that was really important too, just to make sure you're putting the headset on, make sure you're getting it on technicians. We had a couple different technicians help us. We had one who had been at Gulfstream for 13 years, who was very experienced, another one who had started in January. So it was really good to get both of their perspectives when doing our testing, because they really did have different feedback. Another thing that was really helpful for us was MRTK and Mixed Reality Toolkit. This is a library that Microsoft has put out to help with some of this stuff. If you're a web developer or a UX designer, you might be familiar with Bootstrap or Google Material. This is Bootstrap for AR. So they've got a couple things figured out, like how to grab holograms, how to use interactive buttons. They've got some cool usability they've really fleshed out with, like when your finger's close to a button, it kind of has a flourish effect to it. When you press the button, it's got auditory response, so it's pressed. They've got all the spacing figured out. They did the hand menu. That was a really cool interaction. So it's a menu that's always available to you, but it can hide. So it's only when you open your hand does it show up, which is really good to get it out of your way when you don't need it, but it's ready when you do need it. And they also have the tooltips, which we shamelessly stole and use those for our labels as well. So final thoughts, you're going to fail a lot. And I know everyone always says that, designers always say you're going to fail, but with the projects I'm used to, we have stuff where I try a design and we end up tweaking it. But this was we bombed. Some of the stuff we built just straight up did not work, or they hated it. So you're going to fail more than you would on more traditional means, like a web app or an iOS app or something you're used to designing, because it's just so much different. We're in the BlackBerry phase of this stuff, so not everything's going to be fleshed out yet, and we're trying new stuff. So that said, teams have grace with yourselves. We're very used to being very efficient. Our team puts out iPhone apps, and we're down to the hour, pretty good at estimating how long things are going to take. And we run sprints pretty efficiently, and this didn't go that way. We had a lot of things that came up. We had a lot of features that took longer than expected. We had a couple features we didn't even know we needed until we started. So that was really tough. On the same note, leaders have grace with your teams. If you're an organizational leader and you've got a team that's going to spin up an AR project, just understand that it's really hard to estimate. They might not know how long things are going to take. And it's not like you can Google a lot of this stuff. There are a bunch of problems that we had to literally solve ourselves because you can't Google the answer because no one's done it before. So a practical way to put that into practice is to pad your timeline more than you might usually do it. So a lot of our projects have a 10% pad on the end. We call it a runway sprint. If that's something you're used to, maybe add an extra 10%, do a 20% pad. Whatever your framework is, but give yourself a little bit of time for the unknowns and for the new things to come up and for new people to get ramped up on new technology. Again, like I said before, test often with real users. It was really important to get it on people's heads in the manufacturing floor because they had totally different experiences than us. And there was even small things like the hand tracking got weird if a technician had oil or grease on one finger. So they would have a darker finger and then a whiter thumb or something like that. They had different colored fingers, and the hand tracking got kind of weird with that. So that's stuff that we would have seen had we not gotten out into the field and tested it live. And the last thing is iterate. A lot of what I showed you was not our first idea or first version that we went with. So getting out there and testing things and then making those changes is super important, and that requires having a timeline. So hopefully that was helpful for y'all. If you're someone who's in it day in and day out now, hopefully that was some good design review or design ideas for some of the challenges we face. If you're new, hopefully this cleared some of the air and took away some of your maybe confusion around what augmented reality is or how you could bring it in. That's stuff that I wish I had known, when we started this project. So hopefully it helps you too. If you want to talk more, here's my email and my LinkedIn. I'm definitely happy to riff on some ideas. I'm sure some of y'all would come back with stuff I could have done better. And that's what this is all about. And with that, let's move into Q&A.